Welcome to qnawire.
Hi, so for this question, what we know is that we're going to have the reaction of copper Cl2 with NaCN minus in order to generate copper cyanide 2. So first thing that we need to do is identify the actual ions that are going to react and that are interesting for us. In our case, it is going to be only copper 2 plus two equivalents of cyanide minus. This is going to generate copper cyanide 2. Okay, and we know that the formation constant, Kf, it is going to be 2 times 10 to the 30. Okay, so now we are told that we have initially a 0.828 molar solution of cyanide minus. This implies that of copper 2 plus, we are going to have copper as the limiting reagent for this reaction, because in this case we're just adding 2.37 grams of copper chloride. Remembering that copper chloride has a one-to-one relationship in between the amount of copper 2 plus that is going to be released, we can calculate the amount of mole using the molar mass of copper chloride, which is 134.45 grams per mole. With this, the amount of copper 2 plus that we added to the solution, it is going to be 0.0176 mole of copper 2 plus. And we added that to a final volume that is going to always be equal to 2 liters. So the concentration of copper 2 plus is, just to simplify notation, 1.76 times 10 to the minus 2 molar. So with this, we can proceed with our ice table, and using the formation constant, to know what are going to be the values for copper and for cyanide plus. So initially, we're going to have 1.76 times 10 to the minus 2. The amount of cyanide minus that we're going to get in this case is 0.828. And since we know that the formation constant is very high, what we can assume is that all of the copper forms into copper cyanide. And the amount left of Cn minus is going to be initial minus reacted amount. And the reacted amount, it is going to be the concentration that we have of copper 2 plus in our solution. This is mole of copper. 1 mole of copper reacts with 2 moles of cyanide minus. So this is going to become 3.52 times 10 to the minus 2 mole. So the amount left of cyanide minus is going to be our initial 0.828 minus this small amount that we added. So initially we are going to start with 0.793. Let's run it to 793 molar of cyanide minus. Okay. So now our formation constant for the compound, it's going to be, now we're going to take the inverse of that formation constant. Copper 2 plus 2 of cyanide minus. The initial concentration of my solid is equal to the initial concentration that we had of copper 2 plus. So that initial concentration, it is going to be this value, 1.76 times 10 to the minus 2. Oops. This value. Minus 2 molar. Amount of copper is going to be 0. And initial amount of cyanide is going to be 0.793. All of the ice table is going to be in molar concentrations. Now, the amount of change, we're going to call it X. So we're going to produce an X amount of copper 2 plus and an X amount of and 2X amount of cyanide minus. Finally, at equilibrium, we're going to have 1.76 times 10 to the minus 2 minus X. We're going to have X of copper 2 plus, and we're going to have 0.793 plus 2X of cyanide minus. You may notice that this is the inverse reaction of the formation constant. So the equilibrium constant for this, it is going to be 1 over the K of formation. So this is going to be 1 over 2 times 10 to the 30. Which is 5 times 10 to the minus 31. And now, by the definition of the equilibrium constant, the concentrations that we are going to get is X 0.793 plus 2X divided by 1.76 times 10 to the minus 2 minus X. So now we can make an approximation. Taking the fact that the value for the equilibrium constant is in the order to 10 to the minus 31, we would expect the amount of X of copper that is going to be released to be very, very small. So if X is much, much smaller than 1.76 times 10 to the minus 2, then 1.76 times 10 to the minus 2 minus X is approximately the number by itself. And the same thing goes with the much higher number, 0.793 plus 2X, it is going to be approximately 0.793. Recall that this approximation is going to be valid if X is lower or equal than 5% of that C0, of that initial concentration that we have. Okay? So we are going to use the approximation, and then we're going to verify that the result actually matches up. So our equilibrium constant, which is 5 times 10 to the 31, becomes 0.793 times X divided by 1.76 times 10 to the minus 2. Solving for x, it's going to be 1.109 times 10 to the minus 32. So yeah, the approximation works pretty well. The result is reasonable because we know that the reaction is going to be really quantitative because we have a formation constant of 10 to the 30. So we expect the amount of copper cyanide that is produced to be essentially the same amount of copper 2 plus that we added. So now let's remember that X was going to be equal to the concentration of copper 2 plus. Another thing is that here we have a common ion effect because of the excess of cyanide that we have in our solution. So that also helps to bring the equilibrium more towards the formation of the compound. And if we calculate the P of copper 2 plus, this is minus the logarithm of that concentration, which is minus the logarithm of x. And P of copper 2 plus becomes 31.95. And that would be the answer.